In this video, we're going to take a look at solving exponential equations by taking either the common log or the natural log of both sides. The reason why we're choosing to do either common or natural log is because we can punch those into our calculators and get an exact value for that particular expression if we want to know what it is. You can actually take any logarithm of each side. It's just that one of these two is usually more convenient. Now, I will tell you that I generally do natural log. But I'll try to show you one of each in this video so that you can kind of see what happens. Now, in reality, the answer, if it's an exact form, the only difference is wherever you see an log written, you'll see an ln written if it's using natural log, okay? If you're looking at the approximate value, it'll be the exact same approximate value for either one. So if you're taking a multiple choice test, you may want to kind of look at the answers and see what the answers are using and use the same thing. Or if you are given approximate values, then it really won't matter, okay? So let's first take a look at the steps to see what we're going to do in this process. The first step is to isolate the exponential. You want to get your exponential expression on one side by itself. And then the second thing that you're going to do is to take either the common log or the natural log of both sides. Okay, really all that happens in this step right here is you literally just write log or ln in front of each side. Now what's going to happen in the third step, because you do that, you're going to be able to use the logarithmic properties on the sides of the equation, okay? In most cases, you'll wind up using the power property to actually bring the exponent down. And then in some situations, for example, if your exponential's base was 10 or e, you can use the matching logarithm and you'll be able to use one of the basic properties just to bring the exponent down by itself, and you won't have anything left but the exponent. Okay, we'll try to look at one of each so that you can kind of see what's going on with those two. And then last, whatever equation you're left with, you're going to solve that. Okay, so let's just take a look at a couple of examples. In this first one, let's say that we've got something like 5 raised to the x plus 3, woo, is equal to 7. Okay, just something real simple and easy for our first one out here. We already have the exponential expression isolated. That's this part right here. And so what we're going to do is we're just going to write either common log or natural log on both sides in front of each side. I'm going to use common log this first time, okay? So log of 5 to the x plus 3. Now what that means is this 5 to the x plus 3 part right here, that's all the arguments, okay? Because remember, common log has a base of 10, okay? And then here on the other side, we'll just write log 7. Alright, so now what we can do is we can use the power property of logarithms to work on this side right here, okay? So let me just give you a little reminder of what that looks like. Let me scoot up a little bit and we'll put this off to the side over here. Maybe I'll just scoot over a little bit, that might be better. Alright, so when you're using the power property, you've got some log. It can be any base. Alright, so I'm just going to use common log, like the log we're using right now. The argument is going to be something raised to a power. Okay, you saw this in videos from section 4.4 where we were using expanding and condensing properties. Alright, so that's equal to p, the power, times the log of m. Okay, so we can pull that power down in front using the power property, and that's what we're going to do here. Whoops, hit the wrong button, scoot over. Alright, now applying the power property to just this part right here, what we'll see happen is the x plus 3 comes down. And notice, since it is a binomial exponent, I will need parentheses around it. And then I still have that common log of 5 left behind. And I've got log of 7 over here on the other side. Now that one didn't have an exponent, so I don't have to use any kind of property on it. what we do want to do, remember we're solving for x, and so we need to distribute this logarithm to both terms here so that I can manage to isolate this variable right here, okay? So I'm going to do that. You can also alternatively just divide both sides by log 5. It'll give you a little different looking exact form answer that can be rewritten in the form that you're going to see me write if you wanted to go that route. But it will give you exact same expression as an approximate number, okay? So if I distribute, I get x times log 5 plus 3 times log 5 is equal to log 7. Okay, still common log all the way through. All right, now you have to remember something here. If there's no x in a term, that's a constant, even with the log written there, okay? Because log of 5 is just a number, okay? It's an irrational number, this particular one anyway, but it is just a number, okay? So what we can do is we can move the two constants together. This one needs to be subtracted and moved over here. That begins our isolation of the x term. Okay? And then what you can do is completely isolate by just dividing both sides by log 5. So x is going to be equal to log 7 minus 3 log 5 over log 5. Now, the arithmetic that you use when dealing with logarithms is very similar to the way we work basic operations with, say, radicals, like the square root of 2 or the square root of 3. I can't actually combine logarithms together unless they have the same argument right here. And so I'm not going to be able to subtract these two on top. I can't cancel this log and this log because this logarithm is locked to this one with that minus sign. If you have factors, if you had a product here instead of a subtraction symbol, we could do that. But we can't cancel a term. The terms are what you have when you have either subtraction or addition between them, okay? So I can't do any canceling. Really, I can't do anything. The only thing that I could do to make maybe a nicer looking number would be to plug it in the calculator and get a value. This, what you see here, is the exact solution. Now, if you divided by 5 earlier when I told you you could, right back up here in this step, your answer right now may not look the same as mine, and that's okay. Yours is probably correct too. What you may want to do is try to write it. What you'll have to do is combine the two terms that you got and try to write it as one fraction. And if you do that, it should come out to be just like this, okay? Alternatively, you can check yours by plugging yours in the calculator just like I'm going to do here. And we'll look at what the approximate value is so that we can get the exact and the approximate solution. So let's take a look at that. That approximate value that we get is negative 2.5623. That's rounded to 4 decimal places. Okay, so we do get a negative value. That's really not all that unusual that you do get negative values for x sometimes in these situations, so that's not really a problem. Okay, so just double check, make sure you're getting the same thing as I am, and you should be fine, even if your exact form doesn't look identical to mine. Okay, all right, let's take a one. This time we'll use natural log. Okay, let's see. Trying to decide what I want to do with this one. Let's say that we've got e to the 2x is equal to 7 to the x plus 1. We'll make this a little bit more complicated than some of the others, okay? So let's just see what we get. If I do the natural log of both sides, and do notice that this is isolated, okay? I have an exponential on both sides, but that's okay. They're both isolated. So if I take natural log of both sides, on the side over here with the 7 raised to the x plus 1, it's going to use the power property, just like we used on the first example, okay? But on the side over here with the natural log of e to the 2x, let's take a look at that one for just a second. I'm going to pull off to the side over here. What we're going to do there is the property that we looked at in section 4.3. It was actually basic property number 3. Log base b of b to some power x is equal to x, okay? And you may be saying, well, it's not log, and what's the base? Well, the base of natural log is e, right? Log base e is natural log. So if you've got the natural log of e to something, we had what, 2x? Then that natural log of e that you see here is the same as this expression, okay? That's log base e of e to the 2x power, okay? So by using this property here, this is just equal to that exponent 2x, okay? I don't want you to think of it as the natural log and the e cancel each other out. They don't really, okay? That's not exactly what's going on here. It's not mathematically true. I know some people think of it that way, and maybe that does help a little bit, but that's really not what you're doing, okay? You're looking back at the main idea of what a logarithm is, and it's the exponent that you should raise the base to in order to get the argument. And if the argument just hands you that exponent on a silver platter like it does here, then you're lucky enough to be able to know that that's actually just your answer, okay? So that's what we're looking at here. That's going to give us a 2x. Scoot back over here where my problem is. So we're going to get 2x there, and then we'll use that product property on this one again. I wanted you to see kind of a mix-up of both of those things happening in this problem. Okay, so let's try to get our x's together. We do need to distribute. I've got 2x is equal to x times the natural log of 7 plus 1 times the natural log of 7. And this time we need to move the x's together because there are two x terms. So I will subtract that x natural log 7 from both sides. And now I've got two terms that I can't combine that both have an x in them, okay? And if that's the situation, anytime you're needing to isolate a variable and it's in more than one term, but you can't combine the terms and just pull one variable out, what you have to do is factor it, okay? So since that's a common variable to both, we can factor the x out. It gives us 2 minus natural log 7 is equal to the natural log of 7. And then we divide. So let's get a little space down here. Divide both sides by the 2 minus natural log of 7. And we get this. Okay, and again, there are other ways that you can get to that point, so you may have a slightly different looking problem, but it should be very similar to that, okay? Let's take a look and see what our approximate value would be. And that value is 35.97. Okay, I made a mistake there. Alright, so let me see if I can get rid of it. Hang on a second. Let's see. There we go, that cleaned up nicely. Alright, it's 18.4878 if we go 4 decimal places. Okay, and that is how we do our equations where we take the natural log of both sides to bring the exponents down.